Hello. Hi, Raghavendra. Am I audible? Hello. Am I audible? Hello, everyone. How are you all doing? I hope everyone is doing good and safe at the places. So now, from last few days, we have been learning about what is the importance of actually statistics in your data scientist and analyzing your data. So today we will be like covering all and finalizing all the concepts and with few of the examples. Uh, and whether any doubt to you anywhere, just let me know. I'll be clearing it. Okay. So up to hypothesis testing we read about, and hypothesis testing I told you what it is actually all about and how the hypothesis testing has been configured. Okay. And the simplest definition, we read about the hypothesis testing is just a form of statistical inference and that use for the data to form a sample, and that sample is being going to give out you a proper conclusion that will be drawn a conclusion. Either it is towards the population parameter or the population probability. Okay. So examples also I gave you, we performed this example for the hypothesis testing, and these were the all your formula of the hypothesis and how your hypothesis testing has been given. Okay, so again, there is one point, there was one point left behind of the hypothesis testing, and that was majorly about what your about your null hypothesis, your alternative hypothesis, your significant level. These were left of the hypothesis testing, and according to that, in your null hypothesis, it means like any like example I'll give you, any just peppermint has been there, essentially about the oil that has no effect. Okay, and on the pages are being there about the significant algorithms. Okay, every potential example or every potential explanation for something it is not actually about, that will happens only and only if it comes to true. Okay, nothing else. If it is not true, it will not execute the further information. Okay, now if you know, like we did when we had one of the conversation in your hypothesis testing, and that testing we came know about like how your hypothesis testing are being performed. Okay, it is just in like, see, what is hypothesis? Hypothesis just meant for your potential explanation for anything, something it is related to your observation, your thinking, your like whether the program has been true or not as a regression point. Okay. Now, similarly to the significance testing, what your significance testing is all about. So, the significant testing, what it means, like, suppose, now what is your significant testing actually based on, or what is the application of it? Okay, a test of your significance is just a formal procedure for comparing the observed data, and which will claim actually that is that is known as actually your hypothesis. Just a second. So whenever there is a truth addressed, wherever the computational procedures are being there or being performed accordingly to analyze your data, it is being always and always given in experimental study. Okay, to the any of your employees, any of your statistical procedures. That is what the analysis of your variance is. Okay, now you can see in this image about the null hypothesis and the alternative hypothesis, the seesaw of this. And in the seesaw, yeah, alternative hypothesis is being the lowest point and not an heaviest. Okay, and your null hypothesis is lowest and that is my lighter. Okay, and alternative hypothesis is the heavier. Now, what is your chances? Okay, what is your main steps to follow the significance testing? For significance testing, 4 steps you have to follow. First of all, state, plan, solve, and conclude. Okay, these are the 4 things you have to follow up, and remember these 4, and you will not face any of the problem anywhere. Okay, so what it is all about: state, plan, solve, and conclude. Okay, these all of the significance of your testing has been given as an formulation part, that is your either that significance level of your given hypothesis is true, or has a value for which your the p representation of your value has been less than or equals to or to consider as an statistical that significant value. Okay, now for the error part and your the error formations, and whenever your error formations are being there, or whenever your significant formations are being there, these all are being given as a simplest value. Let's perform one of your the p value and the statistical significance. I'll explain you the graph over here. Just give me a minute. Okay, let us perform it. Give me a minute. Okay, so let us perform. I will draw one graph in front of you. Let me know if it's perfectly understandable to you or not. Okay, so in this, the graph is being there. You know how your statistical graph significance graph is there. Okay, so I'm drawing that. Okay, there how your graph is all about. Give me a minute. Yeah, so your statistical graph is to be drawn at the bulged out shape accordingly. Okay, now what happens when you have a graph determined as a true value and a significant value? How you draw your true value and a significant value? You have a value refined and a value determined also. in which you have to find out the basic agenda. Now, what is the basic agenda when you draw your graphs and it represents two? So it has been given a specific value. Okay, now what is your specific value or how it is being done or represented, that depends upon. Now, suppose this is my probability of observation. Okay, this is my probability of observation. Wait 1 second. This is for the probability and this is for the set. And this is for the set. Okay, now this is, I know this is the terminating point. Little it has been given. So this is my terminating point and this is my executional point. Okay, now it comes like, you know, one is your observed and one is your unlikely observed. So in this, these part is your unlikely observed. These both are your unlikely observed. Okay, and it is your observed value. Here, I'll give you 1 point. Over here, it is your observed value. Okay, and observed result over whatever the result it comes under this. This is your unobserved and this is your observed. Okay, now if I tell you, like, if I ask you, like, what is this part? So this is what it actually meant of. This is the important point where you have to know what this bulge is all about. So this bulge is all about the true value and the null hypothesis and the most likely observed. Over here, it is unlikely observed. These 2 points are the unlikely observed. This is the observed and this is the most likely observed. Okay, now we have to know, and we know also, we have a certain point where you have only and only given a specific agenda that is known as your threshold. Now over here 95% over here 95% of your data has been statistical observed. Okay, and it is a significance threshold. It is not the simplest threshold, it is the significance threshold, and every data has been observed over here. So this is the data where each and every of your data has been observed and given as such a value where the able observed p value. Okay, over here we know we will get the p value where the p value has in more of your that observation and your resolving power. Okay, now if I tell you, like, I want these p value and what actually the p value tell us about, it only and only tells us about the statistical significance. Okay, nothing else, because you don't need to remember anything about except that p value. Okay, whenever you perform a statistical test as a p value, it helps you to determine the significance of your result in a relation to your null hypothesis where it is not been given as in proper proper executional point or your null hypothesis. Now, what is a null hypothesis? Null hypothesis, it states that there is no relationship between two variables being studied in one variable is to be one variable not be affected by another one. Okay, now suppose I have to give you an example that you have a sibling. Okay, you have a sibling and you have 2 siblings of yours, and one is very decent and one is very much like naughty. Now you are similar to the decent part. Okay, you are also decent, so to whom you will be choosing? Like, you like decency and punctuality and everything, you are obviously you are being approaching and you are being liking that decent boy more. Okay, similarly to that, you don't have to compare where you are being decent to another one or not. Your image is yourself. Okay, You don't have to remember like, okay, you have these are the decency people or not. You don't have to. You don't have to compare. That is what the null hypothesis meant of, that it doesn't affect other whether its suitability is one observed. Okay, it will only and only result in more than one chance or two chance. Okay, nothing more. In terms when we talk about in terms of supporting, yes, it actually supports more oftenly. What it happens like, either it gives a chance to it gives a chance to the basic suitability or not. Okay, nothing else it will be defining of, but it will be giving a proper the age factor, these observation. Okay, now moving forward, what has happened? Just give me a minute. Yeah, sorry for inconvenience. I guess it was left. Yeah. So now moving forward towards like what is errors and how your errors are being solved with the basic expectations of your the formations. Okay. Now what is your error? Error is one of your differences called between your any of your values or any of that in your statistics. Okay. Now what is the benefit of error? Now we have type 1 error, we have type 2 error, and each of the significance level is your probability. Okay, and even it is being rejecting or being accepting, or the null hypothesis are being there, and this is given to the true value, accepted to be the true value it is. And how your true value is, it is always and always given to your alpha value. Okay, and how your alpha value is being there and how your beta value is there, that depends upon. Nothing is there while defining your alpha and your beta value, or your that part of your the significant value. Okay, it always depends upon the alpha, beta, and your the significance value. Okay, now I forgot to mention yesterday the CLT condition. These are very much important condition of the CLTs. In CLT condition, remember your observation to be independent. Okay, the second is to collect with your randomizations. Okay, now condition is, first of all, these 2 points you have to remember, that is the observation to be independent. Second is you collected with your randomization. Okay, and the condition, what condition there are? There the randomization condition, that the data values must be sampled randomly. Okay, that there should not be any jumbleness or any of that, because it will not help you out with the basic type errors. Okay, now if you have your type errors or any of that, these are the value factors where we defining the basic execution point. Okay, the second one was the independent exception assumption. Now why assumption has been taken? First of all, your sampled value must be independent, and it should not be replacing, either it has been checking the 100% condition. Okay, it is not be accepting any of the point in your beta false, your alpha false, any of that. Okay, let's move to one of your again graph of your type errors. Okay, so in your type errors, let's know about the type error 2 first of all, because it is very much important. And a type error, type 2 error, I'll make about same only. Okay, so if I'll make this, and let me change the color. This, okay, these just as same, these are some graph part only. Okay, so these are the executional point of your what your error point are being there and how it has to be given. Okay, these are the two graphs where your the research techniques should be used. So this is H naught. So this is H naught and this is H1. Okay, this is H naught and this is H1, and there will be one the simulations point. Okay, now, oh sorry, one, two, there will be alpha, beta, any of that. Okay, so these are there. So here will be the beta. Excuse me. There will be the beta, and again there will be the alpha part. Okay, these two part will be there, and alpha and beta. So the difference between these both type error and type error 1, we know that what is the type 1 error and type 2 error. So this is your type 2 error. This is your type 2 error and this is your type 1 error. Now, configuring out what your actually your hypothesis testing in your statistics involves about and deciding what about that rejection, acceptance, according to the null value. Okay, now all these are been defining um as in your real execution point. Okay, nothing else. And your defendant would be judged on the type 1 and the type 2 error. In the type 1 error, the risk of error of or the incorrect judgment of any of the null hypothesis is just a risk in statistical analysis. Okay, as a result, the researchers need to aware of these problems as they have to actually see what happens if you have to collect the trillion of data, the billion of data. So these both will be done as an according with basic more adaptability. Okay, now how it will be coming in, why it has to be solved, it all depends upon your how your data is represented first of all. Okay, your if this part is your null H naught and this has to be written as 1 minus alpha, okay, and this is to be written as 1 minus beta, so what is the difference between both of them? Both are same. Okay, अगर हमने सब में से अगर अल्फा माइनस कर लिया बीटा में से तो वो तो बीटा ही रहेगा ना. अगर वही हमने अल्फा में किया, हमने ये चीज को माइनस कर दिया अल्फा में से, तो वो अल्फा बचेगा. बिकॉज ये पॉइंट्स जो है एंड इसमें भी थोड़ा सा आएगा, ये पॉइंट्स जो होते हैं वो बीटा अल्फा होते हैं. टाइप 1 टाइप 2 एरर है. ठीक है, अब इसमें टाइप 1 टाइप 2 का एरर डिफरेंशिएशन कैसे करते हैं हम? जो टाइप 1 एरर होता है हमें पता है कि वो फॉल्स पॉजिटिव कंक्लूजन है, जो टाइप 2 एरर है हमें पता है कि वो फॉल्स नेगेटिव कंक्लूजन है, ठीक है। अब इस पे क्या होता है, अनसर्टेनिटी होती है, which divides upon the risk of each and individuality to make your this error unavoidable. Okay, the probability of making a type 1 error is more and more significant level as compared to the alpha. Okay, while the more of the probability of making a type 2 error is more depending upon your beta. Okay, now if I interchange both of them, if I'll interchange I naught, H naught and H1, probably both will be executed too. The alpha and the beta position will also execute it. But similarly, if I don't have to reverse it and I'll simply write 1 minus beta and 1 minus alpha, it means same. Okay, nothing has been different in that. So if I'll give you one more example, this is very much important example, and these days these are literally popular about. So if you decide, okay, suppose you decided to get tested for COVID-19 based on your mild symptoms, such as you have a cold, then cough, fever, any of that, your mild symptoms in that. So there would be two errors. It could be potentially or any of the, it could be type 1 error as in false, that is or like false positive, and type 2 as in that your error as a false negative. Okay, in your type 1, what you will consider yourself, it either it should have in result, it should say is like, okay, you have coronavirus and but actually don't. Okay, मतलब आपके पास है कोरोना, आपको है, बट आप अभी अब इसके लिए कैपेबल नहीं हो, ठीक है, बस you have to get rest at your home. Okay, you are being and you have to get isolated, that's it, your type 1 error. But when it comes about the false negative and your result says that you don't have any of your coronavirus but you actually do, means you don't have any coronavirus but आपको हो सकता है. Okay, this is one of the basic the example everyone has to get remember of, that why it has been actually given a basic propaganda. Okay, let's move further. Then we comes to the very important that flow chart about the statistical method. And statistical method, remember one thing, you have to be very much useful to that in your statistical that methods. This is your, remember, this is your head, remember the body structure. Okay, this is your head, this is your two arms, these are your two arms, and these are your stomach. Okay, if you learn like this, you will not forget. This is your stomach, and after that you have the movement of your legs. Okay, these two are your movement of your legs explicitly. Okay, remember explicitly. Head, this is your hand, this is your stomach, this is your legs. Okay, now what it means. In the null hypothesis distribution, we know like every curve below shows your probability of obtaining all the possible result. If no, your result might be repeatedly goes wrong. Okay, if it goes wrong, you have to check your data again and again with your basic vulnerabilities. Okay, similarly, why I said it is head, hand, then your stomach and legs. Your statistical method has been classified into two parts. So what they are descriptive statistics, and another one is statistical inference. Okay, under descriptive statistics, we have both we have numerical summaries and we have graphs. Again, under the statistical inference, Bayesian inference and your frequency inference. And then again, in the frequentized inference, we have interval estimation and hypothesis testing. These are the basic important wordings you have to remember entirely when you study your that hypothesis testing, that your frequency inference. This is gonna help you in your errors. This is gonna help you in the significance testing, in your CLT, then in your the marker tile theory, then your Bayer theory, base theory. Every time, everywhere, it's gonna help you out. Okay, so you have to remember like what is explicitly, what is implicitly, how it is being given a position to basic proportions. Okay, everything when you learned about these abilities, these are given a basic information about your ventures. Okay, and the ventures are being given a basic information about the it's an educator terms we are being gonna use it. Okay. So what are the steps to remember in your hypothesis testing? See, hypothesis testing is very much important because uh, it is actually what it is going to use entirely. Okay. Okay. Now, what are the steps? And like the basic these are the basic graphs we use while performing your hypothesis testing. And what steps you have to remember. These are the steps you have to remember furthermost, because actually if you still don't remember these points or any of that, you are not able to clear them in the hypothesis testing. These first point is your state the hypothesis. Second is your identifying the test statistics and its probability distribution. Okay. The third one is you specify the significance. Fourth, state this is a rule. Now, if I say I have to cover 4 kilometers, okay, and over 4 kilometers, I have 10 more ways to cover that 4 kilometers. But if I go to national highways by that destiny, or I go to the city mark or any of that would, because length is same, it will cover me to the 4 kilometers only, and provide it to me as a destiny. Okay, but the time varies. In cities, we know like that there is more of the rush and all, so it would take time in that, nothing else. Because cities are more and more that time consuming, so you have to remember of like which decision you take properly. Okay, if you don't remember that or you don't take that, you will be in your trouble. Your fifth one is your collect data from the calculation. Okay. Sixth one is make the statistical decision. Seventh, your investment of your decision. Now, yesterday we studied about one tail, left tail, right tail test. Okay, that is known as the Z test only. And in your Z test, we know these are actually given as such a executional point or any of that, which are not able to have a proper estimations. Okay, if it has a proper estimation or any of that, it would not be have a crash jam stacks. Okay, if you have a crash jam stacks, it would probably having the more executional point. Okay, so now this is your one tail test, and this is your two tail test. So in one tail test, we have only one rejection area. Okay, and what are the what are the conditions given in that is your mu has been greater than a mu naught. Okay, and your alternative hypothesis, your mu is greater than your mu naught. Over there it is less than equals to. Okay, and over here it is greater than. Okay, both have the same executional, but in your two tails, your null hypothesis have two rejection areas, in which one tail has only one rejection area. Okay, in the secondly part, in your two tail, the null point is equals to mu naught. Okay, in your mu naught, when it has when it given as in two rejectional point or any of that, so given it has given more executional point. Okay, and how it has been given, it has the more rejectional areas, and the condition for these are the mu naught is equals to mu, that mu is equals to mu naught, and then mu is not equals to mu naught when alternative hypotheses are being there. Okay, what else is left in this? Wait. Yeah, there is one point which is left. Yeah, so there is one point which is left, that is your sampling error and your non-sampling error, which is very much important in your as in type 1 and type 2 error. And in your sampling error, it occurs solely only and only occurs only as a result of using your sample from a population rather than conducting your census or any of that as incomplete enumerations. Okay, when you have incomplete enumerations or any of that, these are much more given as in proper complete enumeration, you can say. Okay, as in complete enumeration when it has been given the basic agenda. So these are what basic differences we have. Okay, in the differences, why it is not having the differences in that, we have a sample differences as in true value and the non-sample differences as in false value. Okay, and both is in false value and your the true value, we have basic what it depends upon, actually what your sampling error depends upon, it depends upon you what the census of your entire population have. Okay, and if your sampling distribution has not given a proper agent of it or the census of it, it is not given a biased result. Okay, if it is not given a biased result, there will be some errors in your climates and your the data output. So how your data has been given as a proper error. Okay, that time also the previously I gave you an example about uh, male and female, the total population of male and female in our country. Okay, suppose if we have 50-50 ratio of your male and female, there the sampling would take a proper characteristics about either similarities. Okay, ratio we have, but it depends upon the root. The root task should be a different one. Okay, that will eventually be apparent to see about the population, because that sampling would not be mean and have a proper average also in their random distributions. Okay, similarly in the non-sampling errors, it has been given a cause by factor other than or related to your sample selection. Okay, it actually refers about the presence of your any of your factor giving a claim, the claim of your additional claim of your additional achievements. Okay, over here the equivalent to that, so it refers only and only to the presence of your the factor, and in your factor present it has given the basic the root true value, which is depending upon the population only, and it can be included or excluded at the same census part as in that part of your non-sampling. So why do we measure error? So the last for today is why do we measure error? Okay, now if I ask you why you study? Okay, if I ask you one question, why you study? So you will give me the answer for our future, for our passion, or for any of for a better life, any of that. Obviously, you will give me this answer. So similarly to that, like why do we measure the error in that? For the measuring the error, first of all, we accepted that each and every data collection process, particularly if the data is obtained from a sample survey. Recently, I just came across one of a survey that my me has made about on that survey monkey. Okay, and that sample, the survey was collecting each and every without recommendation of anyone. Okay, like I just entered name, phone number, that's it. And that personal detail also it was taking about the email, your recognition, any of that. But it is not basically public died or any of that, because I haven't recommended. Okay, so and I haven't gave a key access. So similarly to errors also, if you have given a proper data collection, we expected like it hasn't proper data exception. Okay, and the collection also, so it will obtain some of the sample surveys in that. Okay, although we know like the non-sampling error is too difficult, and it is very much difficult to measure itself, because actually sampling error can be measured the indication level, and to the indication level it exists also, that the user can get a proper information about the basic the availability. Okay, so these were the points to be given for that, and for to determine the standard deviation of your population, you have a formula also. SEX is equals to S to the under root of n. Okay, so now what is S? It is the standard deviation of your population, and SE is your SEX is your standard error of your mean. Okay, and whenever it has been given towards your executional point or any of that, it hasn't given your the number of size or number of observation of your sample have. Obviously it has. Okay, the sampling of your distribution have the number of observation. So that is how it has been concluded. I hope it has been clear to you. Each of your graphs, theorems, everything has been clear to you as a hypothetical and probability part. Any doubt to anyone? Do we have any doubt? No doubt to anyone? Okay. Okay. So it was all till now. If you have any doubt, anything, just let me know. Okay. It was all about that. So rather we will be moving forward. Tomorrow might be. No doubt to anyone? Tomorrow might be we will be going to that of your implementation and all. So it okay. Yeah. Thank you.